Good morning, everybody. Mr. Jamnik here. Hope everyone's doing well. Getting back to the world of probability and thinking about the I can statement about theoretical probability, um, understanding what the condition is, the favorable outcomes when it comes to probability. And we talked upon it last week, and now we're going to move in. I'm going to show you guys a couple different examples. And you can use some of this stuff, for what you have like around the house. But just to show you guys, so in front of me, I know I touched upon it again last week, but I have all these dice. So I want to show you guys as I put the dice in the bag. We got some green. So we got one. We got the red. Oh, sorry. Got a red one. Got another red one. Okay. We got a blue we're going to put in. Okay, so I'm going to take all these dice that you see here. I'm going to place them in the bag. In the bag. Okay, got the dice here. Put them in the bag. Got the dice here. Put them in the bag. Okay, and so right now I have the bag of dice. Okay, I mean you could do it with candy, like I said, M&M's, Skittles. You could do it with various stuff that has different colors. But just to go over a couple different examples. So up here on the board, I put the dice of the colors that I have. So R stands for red, O is orange, G is green, and B is blue. So you can see I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have a total of in this bag of 16 dice. That's a total of all the colors together. So 16 is my total. And I'm doing 16 as my total. 16 is going to always become the denominator because that's what I'm going to be pulling out based on the probability. Okay, and when I'm looking at that, you may ask upon what one color or combining the two or three. There's many different ways you can do it, but just starting off with you guys. So if I ask you, so when you have this, it says P and it has in parentheses the O. The O is the condition, which means that this is what I'm asking. What's the probability that I would pull a O, or in this case an orange, out of a bag of 16? So the probability is the favorable outcome. That's going to be the numerator, and then of the O for orange, and then the total is of the 16. So because again, I'm not looking, I'm just thinking. I know that I have in here because I put up the totals. I have 1, 2, 3 orange in the bag. Okay, so if I reach in this bag right now and I want to see what's the probability, that I'm going to choose an orange out of 16 total dice, but I only have 3. So I'm going to reach in, I'm going to pull out without looking, and I pull out a red. Okay, so I pull out a red. Okay, same thing. If I pull out again, now I even have a blue. Okay, so you can do this and you have different possibilities. But again, I know that if I'm looking at the bag and thinking about it, right, without looking, I know that I had 1, 2, 3 orange. So it's going to be the probability of me picking an orange dice out of the bag of 16 is going to be 3 of the 16. Okay, so the probability is the favorable outcome. So I have a 3 dice chance of getting this out of the bag with a total of 16 dice that vary in different colors. Then if I even think about this, you got to think, can I break this down and reduce? And we go back to reducing fractions because you think about like ratios. So you can always do that to bring the numbers down or the fraction. In this case, can anything go into 3 and 16? And in this case, it can't. So the probability of getting an orange out of the total number of dice would just be 3 of 16. 3 out of 16. So I go in, like I said, grab the dice, I take it out, and the probability of me getting, and look, I got an orange. So again, I have 3 out of 16 to get the orange. So this is how you guys are beginning to understand how when you're doing probability and thinking about all the different outcomes. So again, the P stands for probability, which is the favorable outcome, which is going to become the numerator. Okay, and then the condition which is what you're pulling out of depending on the numbers. Okay, and then that's going to be the number up top. Okay, and the probability is of the 16 that you have. So let's give another example. Let's think about it. If I told you guys what's the probability. Okay, so let's erase this. Okay, don't forget we have a total of 16 dice in the bag. So probability, okay? Let's say, let's go red, right? R for red. So again, P is probability. I know I have a total of 16 in the bag, so that's going to go here. And again, I'm just looking. Now, you're going to know how many colors are in there, but the thing is, they're asking the probability of me picking one of those colors out of the bag. So again, I'm looking. I got 1 red, 2, 3, 4, 5 red. So if I reach, again, just to show you guys, if I took the bag and I reach down into the bag, I have 5 out of a 16 chance probability of picking out a red. So it would be 5 for the numerator and 16 for the denominator. So my probability is 5 out of 16. Then I look at this number. Can I take this fraction, 5/16, and reduce it any more in simplest form just to help break down? Because eventually you're going to move in towards taking this into a percent. But in this case, if you look at the 5, you know 5 is a prime or composite. It's a prime number. So that means that it cannot go into 16. So this one will remain the same. So the probability of me choosing a red dice out of the bag of 16 would be 5 out of 16. Okay? Same process that you keep doing. You have to see what's in the bag. Obviously, you need to know how many are in there prior. So, if you're at home and you have, like I said, Starburst, Skittles, game pieces, the dice that I have, anything you want. Even my daughter right here, when she was younger, she had all these like magnetic pieces that have like the different colors here. So you can do, it's limited what you can do of all these different things. So let's take one more, okay? We did orange, we did red, and let's go to green. So if we do green, okay, again, 16 is my denominator, because I know that's how many are in the bag that I'm looking at green. I had 1, 2, 3 green. So it goes back to the same thing what we had orange. So I have a 3 out of a 16 chance to pick out a green dice from the bag. Okay? And again, then I ask myself, could I possibly reduce this fraction in lowest terms to help me along the process when I have to convert into a percentage? But again, 3 is a prime number. 3 cannot go into 16. So again, the final answer would be 3/16. So some of them are going to work out and some of them are not. It's just based on the final condition that you have of the number of colors and what you're asked to be, taken out to figure out. But you can also do it with various colors as well, too. So let's just think about it. If we took, what's the probability of getting, let's say we'll do blue, and we'll do, what do you guys want to do? Let's do green again, okay? So now you're taking the 2 and thinking, you're still using the bag and thinking about it, but now I'm asking you again, so how many total are in the bag? Okay, we know we have 16 total in the bag. But now we want to see what's the probability if I put my hand in the bag that I would actually choose a blue or a green. So again, you need to combine these two to add them, and that's going to become your numerator. So let's see with the blues. We got blue and green. 1, 2, 3, 4, 5, 6, 7 total now. So we have 7/16. Okay? So the probability of me putting my hands in, grabbing a blue and or green is going to be a 7 out of 16 chance for me to get those 2 colors. And again, we think back, can anything go into 7 and 16? We know that 7 is a prime number, so nothing can go into 7 but 1 in itself, so it has to remain the same. But just for sake, so you guys can see the difference, let's say it was 4. Let's say we had, let's just put this here. We have 4 yellow, okay? Do yellow, 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 yellow. So if I know that probability is going to remain the same, we'll still keep 16. Okay, we can just eliminate some colors. I just want you guys to get the visualization of how you can eventually reduce this and then move on to creating a percentage. So let's say the probability is still 16. We took out the other colors and we added just a 4, yellow in this case. So we're going to put Y for yellow. And then we're looking again. Told you guys we're going to keep the 16 as the denominator, and we have a 4. So now if I went in and I say, okay, so I looked in here, I want to grab a yellow, and I know I have a 4 out of 16 chance to grab a yellow. Okay, great. So 4 becomes my numerator, 16 remains my denominator. Then I look at that and say, okay, so can I reduce this to help me begin converting the process of a percentage. In this case, absolutely. So just like we did, throughout the year, if you take a numerator and a denominator, we got 4/16. Okay, you need to take the division sign and then ask yourself what number. Now it could be different numbers. You're going to have to keep breaking down to simplest form until it's reduced into lowest terms, right? So if you look at 4 and 16, what number can go into 4 and 16? Has to be the same number, don't forget. Okay, so think about it. There's different numbers you can use. Okay, so let's say we chose the number, let's do 2. Okay, we do 2 and 2. Okay, so again, you're going back. 2 goes into 4 how many times? Goes in 2 times. 2 goes into 16 how many times? Goes in 8 times. So take a step back and look. You're like, okay, 2 eighths. Help me out to understand, to convert, to reduce into lowest terms. But then, now you got to keep asking, is this reduced in lowest terms? And then you should know it is not, right? What can go into 2 and 8? Yes, exactly. We know that 2 can go in itself 1 time, and 2 goes into 8 how many times? 4. And then you look at the 1/4, we know that this is done, this is in lowest terms. But just to show you guys, depending on what number you pick. So we started with the 2. Okay, let's say I didn't want to use the 2. Let's say, again, you have 4/16. I want to not use 2 now, I'm going to use 4. Okay, so if we use 4, right, how many times can 4 go into itself? 1 time, absolutely. And then how many times can 4 go into 16? 4 times. And then we are done into reducing lowest terms. So this process took us just one step, where if we use the number 2, which you can, you just have to break it down in a couple other steps to figure out what the simplest form is. So that's the basic understanding. And then we're going to go to beginning to understand how to convert the 1/4, which we already touched upon. But when you're thinking about probability, you're going from the numerator and denominator, you're reducing the fraction if you can, and then you're going to convert 1/4 into a percent. And then you can also think about, for this case, for money and other ways to help you when we have to convert, just like we did with decimals, percents, and converting and using division. But again, just kind of backtracking what we started. Okay, the whole point of when you do probability is you want to get an outcome, and you want to get a favorable outcome. What you're going to do, because again, if you're thinking about candy, when you buy something that has multiple colors, multiple flavors, there's a particular one that you like, right? So when you're thinking about that, which one do you want to grab? So if you dump all the candy out, so just like you could change it. So you could say, these are Skittles, because I love Skittles. So if I dumped all these different colors out and I looked, I'm like, okay, so they have a bunch of various colors in here, and I counted all the colors that I see, I put them in here, and then I explained that in the bag here I have 16 different 16 total Skittles, and in the bag of Skittles I have a couple red, I have 3 orange, and 2 blue, and so on. So the probability of me going in and grabbing one of those would be based on the total outcome of the numbers I have. So this is where you come in to think about the probability and then theoretical probability of getting an outcome. And again, there's many different ways you can explain this and you can show it. You think about a deck of cards. How many cards does the deck have? How many suits does it have? From red and black, diamond, to the jokers, to, the aces, and there's all different things. So eventually I'll show you guys that too, where you can think about the probability that people use. Because you think about the games that people play, card games and stuff, it's all in the mind of how you try to understand like what the outcome can be if you pick this one or if you play that card, if you choose that. So this is why, you have to try to think about like the total outcome based on what you have. So I'm going to go over a couple more examples, but again, as you are looking at this throughout the week, just think about this. And then it's going to ask you too if you can convert into a simplest form. So if I took this, let me just erase this. Okay. Because fractions, I know some people get confused. So if we just said that there was, 5 purple Skittles, right, that you can choose, and total in the bag of Skittles was 20. So the total outcome is 20 Skittles that you have in your bag, and you know that there are only in the bag 5 purple. So what would be the probability if you reached in the bag that you'd be able to grab a 5, right? So, I mean, grab a purple out of the total. So it would be 5 purple over the 20, because that's your chances of grabbing an actual purple. And then you need to continue to think about if you can reduce into simplest form, lowest terms. And I know if I look at the 5 and 20, you think about factors, multiples, and this is how you guys will continue to figure out what's going to break it down for you. So you can think about between the number 5, which is the numerator, and 20, which is the denominator, what can go into both numbers that's the same number that's going to help you reduce it even further. So I know 5 can go into both numbers, right? 5 goes into 5 one time, and 5 goes into 20 4 times. So if I look at the 1 and 4th, we know that we cannot break this down anymore, right? We know that the 4 is a composite number, but the 1 is not. So therefore, you cannot convert this to any more than what it is. So the answer would be 1/4, okay? And let's do one more. Let's do 12 and 24. Now, a number like this, when you're working on, okay, there's different numbers you can choose, and that's why if you do the factors of 12 and the factors of 24, it can help you break the process down quickly. But again, it's entirely up to you about what numbers you're choosing to use. So let's say, I'm not going to go with the obvious. We can use 12, but just to show you guys the differential. So we're going to divide. Well, we can say, all right, I'm going to use 6, okay? So if I use 6 and 6, all right, 6 goes into 12 how many times? 2 times. And 6 goes into 24 how many times? 4. Okay, so now we have our new fraction, which is 2/4, which we look at, and we should know that, again, this is still not reduced to simplest form. So, again, we're breaking it down. 2 can go into itself 2 times. 2 can go into 4, right? So 2 goes into 2 one time, and 2 goes into 4 twice. So this answer would be 1/2. Now we figured out that we got it down to prime numbers. We cannot reduce anymore. This is our answer in lowest term. And going all the way back to retracing our steps, the probability of choosing 5 purple out of a 20 bag of Skittles. Okay? So just to show you guys here, same thing. I'm going to leave this up here. We have 12 over 24. Put this line there. So if we do that, I chose 6. But you guys should know if you're doing factors and thinking about the number, you know that you can use what number? 12. This is going to help the steps, that you could skip. You'll see. How many times can 12 go divided into 12? It goes 1 time. How many times can 12 go into 24? 2. 1/2, 1/2. So you're still getting the same outcome. It's just the process is 1 step quicker, or 2, depending on what numbers you choose. But again, as you're doing the probability and thinking about the denominators and the numerators and the outcomes and the condition that you're trying to get, you're going to have to take the probability, convert it to a fraction, and then change it to a decimal. But we'll get back to all that. So I just want you guys to make sure you're understanding, the same thing of probability. So try it at home with your family, or if you're on, FaceTime or something with your friends. If you have a bag of M&Ms, anything that has different kind of colors in it. And it doesn't have to necessarily be food. You could do construction paper, anything else that you can maybe find, toys, pieces, all that different types of things. And then from there, then put it in, and think about, okay, so you went to your parents and, you had a bag of Legos. And inside the Legos, you had all these different pieces from yellow, green, and then you told them the total amount of pieces in the bag are 100, right? Because the pieces are small. And then you can say, out of the 100, 32 are green. So, give them practice so you can see you're working it out with them, and vice versa, to understand the process of finding the probability of getting something, because that's the whole thing. When we want to get something, we want the greatest probability that we can get what we want, at the shortest distances possible. Okay, so again, reach out, look at the resources and the materials and the videos, and then just continue to use that as the guideline to figure out probability and theoretical probability about outcomes and conditions. All right, have a great rest of the day, and I will see you later.